Okay, our next topic is we want to find the cross product of standard unit vectors in R3. We want to find the cross product. We want to find the cross product of standard unit vectors. Standard unit vectors in R3. From our previous knowledge, we know that what are the standard unit vectors. So this is our 3D space. Here we have X, this is Y, and that's Z. This is the origin. And we know that what is the unit vector along x-axis? The unit vector along x-axis, it is denoted by I. Unit vector along y-axis, it is denoted by J. And the unit vector along z-axis, it is denoted by K. And we want to find their cross product. So first of all, let's write them. The vector I, it has the components 1, 0, 0. The vector J has the components 0, 1, 0. The vector K has the components 0, 0, 1. And we want to find their cross products. How can you imagine this thing? First of all, you have to draw a circle. You have to draw a circle, and on this circle you can make an arrow anti-clockwise. You can make an arrow anti-clockwise. Here you can write the vector I. This is the vector J, and here we have the vector K. So what is I cross J? It will be the next vector. I cross J, it will be equal to K. What is J cross K? J cross K, it will be equal to the vector I, and then K cross I. K cross I, this is equal to the vector J. This is equal to the vector J. And the second thing you need to remember is the following, that is, when I take the inner product of a vector I with itself, it will be equal to 0. I cross I equal to 0. Similarly, J cross J, it will be equal to 0, and K cross K, it is also equal to 0 because of the property which we have discussed above, or you can say the angle between I and itself, it is equal to 0. It is equal to 0. The next thing you need to remember, it is the following, that when we change the order of these two vectors, when we change the order of these two vectors, let's say here instead of I cross J, when we write J cross I, it will be equal to minus K. Similarly, K cross J, it will be equal to minus I, and I cross K, it's equal to minus J. So in general, remember this thing, I cross J, it is not equal to J cross I. Like in the case of the dot product, we know that the dot product of two vectors, it is commutative. That is A dot B, it will be the same as B dot A. But in the case of the cross product, it is not equal. That is I cross J, it is not equal to J cross I. Okay, next we have some properties of the cross product. Okay, here we have some properties of the cross product. The first property says that A cross B is equal to minus B cross A. That's the first property, that is A cross B, it is equal to minus B cross A. And similarly we have these other properties which you can remember from, for example, this one. If a vector A, it is multiplied with number C, you can bring out this number C outside the bracket and just take the product of this number C with the product of A cross B. You don't have to do the other calculations. Suppose that if I give you, that is A cross B, A cross B is, it is equal to I minus 2j plus 7k, and my question to you, find this thing 5a cross B, 5a cross B. Then you don't have to do anything else, just multiply this 5 with A cross B, and then you will get the answer. So it's equal to 5 minus 10 j plus 35k. By using this property, you can find this thing. The third property says that if you have A cross B plus C, you can distribute A or the cross product with B and C. That is A cross B plus A cross C, A cross C. And similarly we have the other properties. Similarly we have the